Okay, these are some exam review problems that are going to be very similar to what you're going to see on your exam. Let's start with the first one on your exam review sheet. It's number 4 on page 162. It says y equals the absolute value of x plus 1 minus 3. It wants us to estimate the x and y intercepts from a graph. Okay, actually, I'll probably ask you to find the x and y intercepts. I probably won't say estimate from a graph. So find the x and y intercepts. You could do it from a graph. I mean, obviously you could type this in your calculator. But I would rather do it algebraically, so because then I know for sure I got them right. I'm not estimating. To do that, I'm going to plug in 0 for x, because I know that if I plug in 0 for x, that's going to give me the y-intercept. Okay? So let's plug in 0 for x. If I do that, I get y equals 1 minus 3, which is negative 2. Plug in 0 for x. So that gives me the y-intercept. Now to find the x-intercept, I'm going to plug in 0 for y. Okay? Because if I plug in 0 for y, I know I'm talking about the x-intercept. Now because this is an absolute value, there could be 2 of them. So there could be potentially 2 answers to this x-intercept. So let's go ahead and do it. When I plug in 0 for y, I get the absolute value of x plus 1 minus 3. I would add 3 to both sides. And then I would take what's inside here, so x plus 1, set it equal to the positive 3, and also take x plus 1 and set it equal to negative 3. Those are the 2 equations you need to solve from an absolute value. Take what's inside, set it equal to the positive and the negative. Now I'm going to subtract 1. I get x equals 2. So one of them is x equals 2. This one is negative 4. Okay? So here's my x-intercepts. Here's my y-intercepts. And that's all I'm going to ask you for. Now you can always double check this with the graph in your calculator, which might be helpful. You can use your calculator on the whole exam. We'll go ahead and just type this in. You get, let's see, math, absolute value of x plus 1 minus 3. And you can see that these are right. Then I could zoom in on this, but we got the right answers. There's the x-intercepts are at negative 4 and 2, and then the y-intercepts at negative 2, which is exactly what we got here. X-intercepts at 2 and negative 4, and y-intercepts at negative 2. All right, you're also going to have to solve equations like this with fractional exponents. So this is just a power equation where you're solving for a variable in the base. All right, this is the next problem in the exam review. It's on page 164 of your book, number 82. If I was doing this problem, I'd probably raise both sides to the 4/3. Obviously, you could, let me actually rewrite this. You could take the log of both sides as well. There's different ways to solve these, but if this is 3/4 equals 27, I would raise both sides to the 4/3. Because if I do that, this 4 cancels, this 3 cancels, and I end up with the left x plus 2. And on the right, I end up with 27 to the 4/3, which I'm going to write 27 to the 1/3 to the 4th power, because I know the cube root of 27, which is what this is. It's the cube, 1/3 is really the cube root. It's just 3. So it's 3 to the 4th equals x plus 2. And then I can subtract 2 from both sides, and you get x equals 81. Oh, minus 2, sorry, 79. You're also going to have to solve absolute value equations like this, where you take x, what's inside, set it equal to the positive, and also take what's inside, set it equal to the negative. So I would add 5 to both sides, and you get x equals 15. And then add 5 to both sides here, you get x equals negative 5. So there are 2 solutions to this equation. Both of those will solve the original equation. Okay. I could give you a more complicated one. This actually doesn't involve any absolute values, but it's solving an inequality. Using integral notation is something you'd have to do as well. This is the next one on page 164. I would distribute and get 2x plus 14 minus 4 is greater than or equal to 5x minus 15. So I just distributed both of these values. This turns into 2x plus 10 is greater than or equal to 5x minus 15. I would subtract 10 from both sides. And also, I would subtract 5x from both sides. This gives you negative 3x is greater than or equal to negative 25. Divide both sides by negative 3. Now when you divide both sides by a negative, you have to switch the sense of the inequality, so the inequality changes. And you get 25 thirds. Okay? In interval notation, that would be negative infinity all the way to 25 thirds, including 25 thirds. So this is the answer that we want in interval notation. Also know how to write complex numbers in standard form. So I squared is really negative 1. So I would make this negative 1 plus 3i, because standard form for a complex number is a plus bi, where the real part comes first, and then the imaginary part. All right. Let's try one more then. You have to solve regular equations like a quadratic equation. To do this, you could try to factor. Factor if you can. Let's see. X minus 5, x plus 2. No, I don't think this factors. So we're going to have to use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's 2 plus or minus the square root of 4 minus 4 times 1 times 10 all over 2 times 1. Okay, this gives me 4 minus 40 is negative 36. This is just 2. The square root of negative 36 is 6i, right? Because I can pull up the negative 1. The square root of negative 1 is I. And the square root of 36 is 6. So then I have this. I can simplify, though, because 2 goes into 2 one time. It goes into 6 3 times. So this becomes 1 plus or minus 3i as my two solutions for x. Those are my two answers for x, which are both complex numbers.